So, Elon Musk wants to put giant AI data centers in space. I know, it sounds like something straight out of science fiction, right? And honestly, on the surface, it seems completely and utterly unworkable. But what if the picture we all have in our heads about this is just completely wrong? Let's get into it. When this idea first started floating around, the reaction from a lot of experts was pretty much instant. You hear things like this quote, "It can never, ever work. It is impossible." And you know what? That's a totally fair reaction, especially if you're picturing what most of us are. Because that's really where we have to start. This whole concept is massively misunderstood, and it's that common mental image that most of us have that makes it sound so absurd. We all tend to imagine, something like the International Space Station, but 100 times bigger. This single massive building floating up there, just crammed with servers and surrounded by miles of solar panels. A giant monolithic structure that would be an absolute nightmare to build, let alone maintain. But here's the twist. That's not the plan. Not even close. According to former SpaceX engineers who would know, the actual approach is way more clever, way more scalable, and frankly, a lot more achievable. The real plan is all about AI constellations. And this slide, right here, just makes it all click. The myth, on the left, is that giant fragile building. The reality, on the right, is a distributed network of satellites. So stop thinking space station. Start thinking Starlink. But instead of beaming down internet, each one of those little satellites is its own node of super powerful AI compute. That makes it scalable, and it gets rid of that terrifying single point of failure. So what exactly is an AI compute constellation? Well, it's a huge network of specialized satellites. Each one is its own self-contained unit, packed with AI hardware, powered by these massive 100-kilowatt solar arrays. And it's got the same kind of autonomous, self-driving collision avoidance that thousands of Starlink satellites are already using today to dodge each other. So that brings us to the real question, right? Why? Why go to all this trouble? Why not just keep building data centers here on good old Earth? Well, the answer really comes down to one critical thing: speed. This chart just lays out the bottleneck perfectly. If you want to build a massive 1 gigawatt data center on the ground, you're looking at 2, maybe 3 years. You've got to get the land, fight for the permits, hook into the power grid. It's a whole thing. In space, with Starship launching all the time, you could deploy that exact same gigawatt of compute power in a matter of months. We're talking orders of magnitude faster, with 0 land permits and 24/7 access to solar power. So here's the key takeaway. This isn't just about moving data centers to a new location. This is about winning the AI arms race. In this new world, AI capability is directly tied to how much compute you have. So the company that can deploy that compute infrastructure faster than anyone else, they have an almost unbeatable advantage. But let's be real, a plan this huge isn't something just any company can try. It depends on a very unique set of capabilities that have been built up over 2 decades. And that brings us to the SpaceX advantage. See, SpaceX doesn't have to start from scratch here. They can literally pull flight-proven components right off the Starlink production line. Things like reaction wheels, star trackers, all the guts of a satellite. They can use the absolutely insane launch capacity of Starship. Their supply chains are already running hot. And, this is critical, they can use the existing Starlink satellite network as the communications backbone to get data to and from this new AI constellation. This whole thing creates this incredible synergy across Musk's companies. Just think about it. The plan is to put compute hardware from Tesla onto satellites that are basically modified Starlinks, launch them with Starship, all to run AI models for his company xAI. It's a completely vertically integrated ecosystem that literally no other company on the planet can match right now. Okay, even with that advantage, I'm sure you still have questions. I mean, a plan like this raises some very real concerns about operating at this kind of scale in orbit. So let's tackle the biggest ones. First thing that comes to mind, space debris. If you're putting thousands, or heck, maybe even millions of satellites up there, aren't you just asking for a Kessler syndrome catastrophe, where one collision kicks off a chain reaction that makes orbit totally unusable? Well, the answer is all about active, smart management. These aren't just passive tin cans. The satellites are intentionally spaced out, with tens of kilometers between them. They're constantly making autonomous maneuvers to avoid collisions. A big chunk of their fuel is set aside just for that. And unlike a huge, slow target like the space station, these smaller satellites are nimble. They're designed from the ground up for a safe, controlled deorbit at the end of their life. All right, next question, heat.
a data center generates a ton of waste heat. How in the world can you possibly cool thousands of them in the vacuum of space?
The solution is actually pretty elegant. Radiative cooling. The physics are simple. Heat naturally radiates away from a hot object towards a cold one, and space is very, very cold. This isn't a new idea. In fact, SpaceX is already an expert at this. They have to reject enormous amounts of heat from their Starlink satellites every single day. It's a proven tech that just needs to be scaled up. And the final big hurdle, solar radiation. You know, the space environment is incredibly harsh. Radiation can absolutely wreak havoc on sensitive electronics. So how do you protect the hardware?
So here, the strategy is more pragmatic than you might think. Instead of spending a fortune on expensive radiation-hardened components for everything, it's actually more cost-effective to just design with redundancy. You know, have multiple flight computers, for example. And with their mass production factory, it's cheaper to just accept a shorter lifespan and plan on replacing satellites as needed. Each new one is cheaper to build than the last.
So if the technical hurdles are solvable, what's the ultimate goal here? What's the economic potential? Well, this is where the numbers start to get truly mind-bending.
Let's talk money. According to one analysis, a single one of these AI compute satellites could generate up to $15 million in revenue every single year.
And that's just one satellite. The real beauty of this whole constellation idea is that it's infinitely scalable. You can just keep adding more. To meet future demand, you can stack them in different orbital shells, creating these layers of compute that surround the Earth, as one engineer beautifully put it, like the rings of Jupiter. And when you combine that kind of revenue potential with near-infinite scalability, you end up at a truly staggering number. The thinking is that pulling this off could position SpaceX to become a $10 trillion company. They'd effectively become the foundational cloud provider, the AWS of the future for the entire AI industry. Which leaves us with one last big thought. This whole plan isn't just about building data centers. It's about controlling the entire pipeline. So if the future of artificial intelligence is really going to be built in orbit, the real question becomes, who builds the roads to get there?